children, in today's video we will discuss about force and pressure. So we all might have seen that in our daily activities, maybe while opening the door or shutting the door, lifting or pushing a weight, or squeezing a bottle of ketchup, cutting vegetables, and different other activities, we always apply some kind of push or pull. So what is force? A force is a push or pull that is applied on an object. Now, if I ask you, what is a push or what is a pull? So push is a force that is applied on an object to move it away from our body. However, a pull is a force which is applied on the object to move the object towards our body. And the force can be both push or pull, or sometimes the combination of both. Now, have we ever seen force? No, we have never seen force, but yes, we can realize the effect of the force. And as I said that there are certain objects wherein the force is the combination of both. So such objects can be when we are playing guitar, when we have to play music on guitar. So there is both push and pull applied. And scrubbing the floor, again, we scrub the floor, we scrub the floor while moving our hands in both the directions. Then sawing wood. So saw is also moved in both the directions, to and fro. Similarly, rowing a boat. So all these are examples wherein combination of both push and pull is used. Force is a physical quantity. So why is force a physical quantity? Force is a physical quantity because it can be measured. So any physical quantity is a property of a material or a system that can be quantified by measurement. For example, when we take suppose any weight or any mass and we measure it, then we term it as say 5 kg, 6 kg, 10 kg, etc. So that is quantified as n kg, wherein n is the numerical value, or this numerical value is also called as magnitude, and kg is the unit. So as mass can be quantified, so mass is also a physical quantity. Now, when we quantify force, we write it as force is equal to say, whatever force is applied, for example, say 10 Newton. So Newton is the SI unit of force, or Newton is the unit of force, and 10 is the magnitude of the force. If we have written F is equal to 10 Newton. Similarly, if we write F is equal to 6 Newton, then 6 is the magnitude of force and N is the unit of force. So force is a physical quantity that is capable of changing the state of rest or state of motion of a particular object or body, and it has a magnitude and a direction of motion. The SI unit of force is Newton. As I said that suppose F is equal to 10 kg, then 10 is the magnitude, and SI unit of force is equal to SI unit of force is Newton. For example, F or force is equal to 10 Newton, then 10 is the magnitude and N is the Newton, or N, this is the unit of the force, that is Newton. So this Newton, it is represented by capital N. Now, one more thing to understand is that force has got a direction. So I'll tell you, because of this, because the force has got a direction, it is a vector quantity. Now, what is vector quantity? I'll let you know about this. So there are two types of physical quantities. One is the scalar quantity and the second one is the vector quantity. Scalar quantities are those physical quantities which are specified with the magnitude alone, and they do not require direction for their expression. And vector quantities are those physical quantities which are characterized by both the magnitude as well as direction. For example, if we have to measure a length of any object, or say length of some cloth piece, then direction is not required here. Irrespective of any direction, whether we measure it from left side or we measure it from the right side, the length of that cloth piece will be same. However, in case of force, if we are measuring it from left side or right side, because of the direction, there can be some change in the effect of the force, and that is the reason why force is characterized by magnitude. So those physical quantities which are characterized by magnitude, they are called as vector quantities. And this is not only force, there are certain other examples of vector quantities. So they can be velocity, acceleration, etc., etc. Okay, now let's be back to understand why force is a vector quantity. So yes, as I said, that direction is required for force. So for example, suppose this is a ball that we see here, and if I'm applying force, say in this direction from the left side of this ball, then the ball will move towards the right hand side. However, if I apply the force from the right side of the ball, then the ball will move towards the left hand side. So direction is involved here because the direction will change the effect of the force applied. So that is why force is a vector quantity. And the SI unit of force is Newton. Once again, it is represented by capital N. However, if the force is expressed in CGS system, then its unit is dyne. In that case, it is measured in dyne. So dyne is the unit of force in centimeter, gram, and second system of the physical units, and 1 Newton is equal to 10 to the power 5 dyne. Now, how do we measure the force? The force can be measured using a spring balance. So this is how the spring balance looks like, and it has got a hook here which helps in attaching the mass. And this spring balance is also called as Newton meter. So as we see here, this is a point. So this point, it shows there is a graduated scale here. So on the graduated scale, whatever point is shown, that helps you understand what is the force applied by the object that we are hanging on the spring balance. So this is how we measure force using the spring balance. And once again, spring balance is also called as Newton meter. There are certain conditions that are necessary for the creation of force. Now, condition 1 is that presence of 2 or more objects. Unless or until there are minimum 2 objects, the force cannot be applied or the effect of the force cannot be seen. As we all know that force cannot be seen, only its effect is visible. So if 2 or more objects are not there, then the effect of force would not be visible. Second, the objects, they must interact with each other, and this interaction can be direct or indirect. So when I say that this interaction can be direct or indirect, I would like to tell you here that there are different types of forces, and the broad classification of different types of forces is contact force and non-contact force. So when I say contact forces are the forces wherein the 2 objects, they are in direct contact with each other. The surfaces of both the objects, they meet each other. They are in direct contact with each other. However, non-contact forces are the forces wherein the 2 surfaces of the different objects are not in direct contact with each other. Example for contact force is muscular force, frictional force. For friction, the 2 surfaces should be in direct contact with each other. However, indirect contact or example of non-contact forces can be gravitational forces. The apple hangs on the tree and still it falls down on the ground. So the 2 surfaces, the surface of the apple and the surface of the ground, they are not in contact with each other. Still the force is applied on the apple and the apple falls on the ground. Then second can be magnetic force. So magnetic force, even if the iron piece and the magnet, they are not in contact with each other, the surfaces are not in touch with each other, still the magnet has the capacity to pull the iron towards itself. So that is an example of non-contact force. Similarly, electrostatic force. So suppose we have rubbed the comb on our hair and we try to pull the bits of paper, then what happens that the paper is attracted towards the comb or a scale or a ruler. So again, here also the bits of paper and the ruler surface, they are not in contact with each other, but still the bits of paper, they are pulled towards the ruler, which is rubbed on our hair. So that is an example of electrostatic force. So this is again a non-contact force, or wherein the two objects, they are not in direct contact with each other. So the objects must interact with each other either directly or indirectly. Now in this, here we see the example. In this image we see, a man stands behind a car, the car does not move. However, when the man pushes the car, he applies the force and the car begins to move in the direction of the force applied. So when he was not touching the car, or when he was not interacting with the car was not moving. And once he started interacting with the car started moving. So there are two conditions which are necessary for creating the force. Sometimes we see that even if the force is applied, the object does not move. So why does the object does not move? So when two forces acting on an object are equal in size but act in opposite direction, we call it as balanced force. And due to balanced force, the object does not move because the two forces which are acting in equal and opposite direction, they nullify the effect of each other, or the resultant force becomes zero, and that is the reason why the object does not move. So balanced forces, they do not cause motion. And the second is unbalanced forces. So these unbalanced forces, they are the forces which act in opposite direction and are not equal in magnitude. For example, here we see that there is some pressure exerted on this book from upside, and some pressure is exerted from the downside, and that is why the book is falling down, right? Had the book been on the table, then the book wouldn't have moved. Why? Because the table surface and the force applied by the atmosphere would have been same, so the book wouldn't have moved, right? So that would have been balanced force. However, in this case, as there is no table surface, if the table surface is removed, then what happens that the pressure which is exerted, the force which is exerted from the top of the book, that will be more, and that is the reason why the book falls down. Or another example can be a man who is applying 50 Newton of force and the other man who is applying 30 Newton of force. So what will happen? Because this force is more, 50 Newton is more, so the man who's applying 30 Newton of force will be pulled towards the man who's applying 50 Newton of force. Yes. So this is also an example of unbalanced force. Let's summarize balanced and unbalanced forces. So balanced forces do not cause change in motion, and they are equal in size and opposite in direction. However, unbalanced forces, they cause change in motion. Yes, so the forces acting on an object to cause a change in motion, they are unbalanced forces. Here again, one man is pulling and the other the other two men, they are pulling again towards their side, but wherever the force will be more, to that side the motion will be caused. So this is an example of unbalanced force. Now let's explore more about the forces. So if two forces acting on a body in the same direction, the net force or the resultant force is the sum of two forces. For example, here in this case, we see that F1 force is applied over this box and F2 force is also applied over this box, and the two forces, they are applied in the same direction. So the net force will be F1 plus F2. So let's solve this. For example, force F1 is of 15 Newton and force F2 is again 15 Newton. Then what will be the net force? Net force F is equal to F1 plus F2, that is 15 Newton plus 15 Newton, and that is equal to 30 Newton. So the resultant force that will be acting on this box will be 30 Newton. Yes. Now let's find out what if the forces are acting in opposite directions. So unbalanced forces acting in opposite direction, they combine by subtraction. And the net force is the difference between the two forces, and the object will move in the direction of the force having larger magnitude. For example, here force F1 is applied and force F2 is also applied here on the same box, but both the forces, they are in opposite direction. So what will be the resultant force? If F1 is greater than F2, then the resultant force will be F1 minus F2. And if F2 is greater than F1, this F2, if this is greater than F1, then the resultant force will be F2 minus F1. So the net force, when they are acting on a same object in opposite direction, they are subtracted. Now, in this case here, we see that a box is there and 10 Newton force is applied from the left-hand side and 10 Newton force is applied from the right-hand side. Now, what will be the resultant force? In this case, both F1 and F2, they are equal. So any can be subtracted. We can even subtract F2. We can subtract F2 from F1 or F1 from F2. So the net force will be F2 minus F1 or F1 minus F2 because the forces are similar. So the resultant force will be 0. These are certain questions which you can solve and find the resultant force or the net force for these. What are the effects of force on an object? So a force can make an object to move from rest. Suppose a ball is at rest position, and if we apply some force on the ball starts moving. So a force can make an object to move from rest. Then a force can stop a moving object. For example, a ball is moving and then somebody stops it with the foot, then what will happen? Or somebody applies some kind of force in the opposite direction of the motion of the ball stops moving, or maybe that the speed is also decreased. So a force can stop a moving object. Then a force can change the speed of an object if it is moving. As I said, if the ball is moving and somebody applies force in the opposite direction to the motion of that ball, then the speed is decreased. Then a force can change the direction of a motion. Suppose a ball is moving and somebody has applied force on the ball in another direction, then the direction of the motion of that ball can change. And force can even speed up the motion of an object. Suppose a ball is moving and someone applies the force in the same direction in which the ball is moving, then the speed of the motion will increase. And a force can also change the shape of an object. For example, here we see that a ball of dough was made, and when rolling pin has been used, then it has become, instead of a sphere, it has taken the shape of a circle. Yes. So the force can change the shape of an object. So these are certain effects of forces.